Hello again. Alright guys, so excuse my finger. I was trying to get some things off my screen. But it is day 7 for this video. So day 7 for you all is to review all of the properties of exponents. So in your packet, you should have seen this paper. And on this paper, on the left side, you'll see all of the properties of exponents names that you have now successfully gone through. So there was only like maybe 1 or 2 of them that in class that you said that you weren't too fond of, but overall I think that you were able to understand those concepts. So this is just a review sheet. Since many of you, your binders are in the classroom and you won't be able to see all your rules. So use this as you complete your assignment, which I'm trying to get was this page. So yours may not be orange, no big deal, but you'll notice at the top it says properties of exponents worksheet, and it's overall just a review of all of the properties that we went over. So I wanted to go over those properties with you and make sure that you were good to go. I know that you can't give me a whole lot of feedback, obviously, because this is not live. So, the first property on this handout is the product of powers property. So the product of powers property, I'm just giving you the same exact example, says when you have 2 powers being multiplied, producing a product, you would keep the base if it's the same. Okay, if it's not the same, this rule doesn't work. And then you would add the exponents. So you would, in this case, because you don't know what n and m are, you would just put n plus m. All right, so we kept the base the same and we add the exponents. That was pretty simple. Now, if I happened to have something, let's see, I'm looking at your handout. I don't think there's any that are really complex, but let's say that I had a problem such as this. We would multiply the coefficients, and then our rule would apply for what would be considered our powers, which are m squared n and n to the 5th power. So I have m, which is the same, keep those the same, add your exponents, and then n stays put. All right, so that's the review of your first property. The second property is quotient of powers property, which your example, it has x to the nth power divided by x to the mth power, all right, or to the power of m, so I can actually say it. So with this one, we don't really know which of these is the biggest, so we're just going to move this up to the numerator, keep that base, and then we would have n minus m. That's all you can do with this because we don't know what any of those variables represent. All right, now my other example, I'm gonna alter that a little bit just because I want to remind you of how some of these can look. So if I had 2 times y to the 7th and then 6y to the 3rd, I would divide or reduce my numbers like normal. So just look at 2 and 6. 6 can be divided by 2 and it would be 3, so the 3 would stay in the denominator. I've utilized my coefficients. And then my y's are the same base. So this is when my rule here applies, which my rule says you keep the base wherever I have the bigger exponent, and then you subtract those exponents. So I would have y to the 4th power. And there's nothing else I can do with this, so that's it. Oh. All right. So our next rule based off this is our negative exponents property. So your negative exponents property, the first thing that you want to ensure that you have is a fraction. So in this case, I don't have a fraction, so I would place what I have over 1, making my fraction. Then I would look to see where I have a negative exponent, and the base that's attached to the negative exponent, both of those pieces would move to the opposite side of the fraction. When I do that, remember Miss Sands taught you that the fraction bar was like a little magic wand. So as they move, your exponent becomes positive, because wherever an exponent is negative, its reciprocal will show you where it's positive. All right, the next thing, there's nothing left in my numerator, so I do have the number 1. All right, so that's how I'm going to get rid of a negative exponent. All right, halfway there. So my next property is the easiest of all 6. It's the 0 exponent property. Anything that has a power of 0 is 1. Meaning, if I had x to the power of 0, the whole thing equals 1. If I had some very crazy problem, in parentheses, excuse my sloppiness, let me correct that. All right, so I have all of that craziness to the power of 0. I don't have to work anything out, because to the power of 0 and anything to the power of 0 will always be 1. All right. The next 2 are the ones that you did yesterday. So I have the power of product and the power of quotient properties. And I'm just going to combine those together because you just did them yesterday. So for instance, if you had 9t to the 7th power and x to the 6th power, and you raise that to the 3rd, this is power of powers. We keep all the bases the same, and you distribute your outside exponent. So 9 becomes 9 to the 3rd. T becomes t to the 21st, and then x becomes x to the 18th. All right, so at this point, I've gone over all 6 of those properties, combining the last 2 properties because they have the same steps. You should be able to complete this handout. Again, it's a review handout. If you have any questions whatsoever, I've given you my contact information, and as far as live grades, email, and the Remind app. If you at any point in time feel like it would make more sense to have a verbal explanation, just live grades message me and ask, or not live grade, anything, message me and ask me if I could give you a call, whether it's that school day or the following day, and we can make sure that I can give you a call and go over the problems with you. All right, so that's it. I'll talk to you tomorrow. All right, bye-bye.